Hello, this is continuation of Geometry Lesson 1-2. This is Part B. Um, our objective is to be able to understand basic terms and postulates of geometry. So here we go. We've got some more undefined terms. We can use actually undefined terms, point, line, and plane, to define other terms, such as a geometric figure. A geometric figure is a set of points. And space is a set of all points in 3 dimensions. Those are some very basic geometry terms. Then here we've got some other ones we're going to build upon as the semester goes. The first one is a segment. A segment is a part of a line that consists of 2 endpoints and all the points between them. There are a few ways to name a segment. You can name it by its 2 endpoints, such as segment AB. And notice that line above, it just is it looks like a line segment and doesn't have any arrows like a line would because it doesn't go forever. It's a chunk. You can cut it out of a line. And so when you name it, you take the 2 endpoints, you put it below. The way that we read that is segment AB, or you could switch the endpoints and call it segment BA. The next topic is a ray. A ray is a part of a line that consists of 1 endpoint and all the points of the line on one side of that endpoint. So an array really, it has an end and then it goes on forever in one direction. And so we always start by naming it with its end. We always start by naming an array with its endpoint. So here we have in the drawing ray AB because A is the endpoint, and then B tells you which direction it goes in. So the order of the points in the name refer to the ray's direction. And every time you name a ray, regardless of what direction it goes, you take the endpoint, write it first, take the other point on the ray, write it second, and always draw the ray to the right, even if the ray goes to the left. You draw the ray to the right, you start with the endpoint, and then you write the direction it's going in, the other point on the line. Now our next concept is about rays, opposite rays. Opposite rays are 2 rays that share the same endpoint and they form a line. You can name opposite rays by their shared endpoint and any other point on each ray, such as ray CA and ray CB. So the important thing about opposite rays is that they make a line. So you have 2 rays here. You have ray CA, and notice CA goes to the left. But they start with the letter C because that's the endpoint. And then they write down A because that's the other letter on the ray. Then you have ray CB, so it's an endpoint at C and it goes towards B. If you put those 2 lines together, you get a straight line, and that's what makes them opposite rays. So let's do some naming of some segments and some rays now. It says, what are the names of the segments in the figure at the right? So let's start with that one. What are the names of the segments in the figure at the right? There's a lot of segments. But remember, a segment is made up of 2 endpoints, so you have to find 2 endpoints. We find one. Here's D. We pick another endpoint, maybe F. From D to F is a segment, so we name it DF. Now when we name that, because it's a segment, we draw a segment above it. Remember a segment? It's a chunk. You can measure a segment. You can figure out how long it is, so you don't put any arrows on it. It's just a chunk you can cut out. That is not the only segment in this ray. If you look at it, there's another point in this ray. There's E. And so you can say, oh, from E to D would be a segment, as well as from E over to F. Now, when you could say FE, DE, FD. Know that those are the exact same things in this case. The order you put the letters for the name of a segment doesn't actually matter. For other things it does, but not for a segment. The next question says, what are the names of the rays in the figure? Remember, a ray needs an endpoint and then it needs another point to go in the direction of. So let's pick an endpoint to start with, maybe E because it's in the middle. Okay, then we need another point that it's going to go towards. So remember, we start with the endpoint E, and let's say it's going to go in the direction of F. So we're going to say E in the direction of F is a ray, just like that. Now, that isn't the only ray that's going off of E. If you look, you could also say from E over to D is also a ray, but notice when I name this one, I'm going to say E because it's the endpoint, and then D because it's the direction it's going in. That's 2 rays. Why don't you, let's move on to the next question. I'll have you come back and finish this one up in a little bit. It says, which of the rays in the part B are opposite rays? Well, let's look at that. We only have 2 rays named right now, EF and ED. So I guess the question for us is, are those opposite rays? If you look at those, if you trace them in the drawing up above, EF and ED, together, do they make that whole line DF? Is every single point in that line accounted for? If so, then those are our rays. And this one, since they both have that endpoint at E, these would be our opposite rays. So we would say EF and ED are opposite rays. There are more rays in this drawing, so I'd like you to see if you can figure out any more rays for part B in the drawing. So I want you to pause the video and see how many more you can come up with. The other 2 rays that I came up with were DF and FD. And even though those have the same letters, because they are rays and those letters are in opposite order, they're actually 2 separate rays. You can see them in my drawing in red and black. The one that goes from D to F is in red, and notice the endpoint's at D and it's going towards F. That's different from an endpoint at F going towards D. If you want to think about it like a lane of traffic, if you're going east, you're not going the same as someone going west. Even if your destination is where they started from, you're still not doing the exact same thing. So be careful when you're naming them that the order does matter in rays. I have another question for you. It says, EF and FE form a line. Are they opposite rays? Explain. I'd like you to pause the video now and see what you think. Explore it, maybe trace them in the drawing, and then decide, pick a side, yes or no, and see if you can come up with a reason why. I went back to the drawing and I traced EF and FE. If you look from E to F, you have that ray, and then FE is the ray to the left. If you notice, they have this shared common ground between E and F. Because of that, they are not opposite rays. They have to have the same endpoint. That's part of the definition. So the reason why is that the endpoints are not the same. That's the only thing that they should have in common. They shouldn't have a space like that in common like they do in order to be opposite rays.